So I'm really excited about today because we're going to be talking about implicit differentiation. And the whole idea of this is we're taking all of our rules that we've learned about derivatives and we're just learning more and more and how do I take derivatives and find instantaneous rate of change of more complex functions. So all of the functions that you guys have been derivating so far, right? You've been doing the derivative of y with respect to x. So that means all of your functions are kind of solved for x, or they're in terms of x. They're solved for y in terms of x. So that's not always how you find a function, correct? Or find an equation. Sometimes we see things we see different polynomials going on here, or equations of circles where x's and y's are on one side and it's not really simple to solve it for y. Because this function, with all the rules you know, if you were taking the derivative with respect to x, you would not know what to do with negative 2y cubed or 4y. And moving x squared and then trying to figure out a way to solve for y or get it in one term of y, it's kind of it's not going to be easy. It's going to be quite challenging. So let's talk about some basic facts to consider. So you may have not realized this, but every time you're taking a derivative, you've been doing it with respect to x. So all the derivatives have happened to x. When you differentiate terms involving x alone, you can differentiate as usual. So what that means is if your equation is f of x equals x cubed blah, 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 all in terms of x. When you differentiate terms involving y, you must apply the chain rule because we're assuming that y is defined implicitly as a differentiable function of x. That sounds like a mouthful, but what we're saying here is if we have the derivative of something with respect to x, so d over dx of y, what that is dy over dx. Whereas if I take the derivative with respect to x of x, that becomes dx over dx, right, which is 1. So that's kind of where this is all coming from. Y is the derivative of x a constant, moving through all this type of things. So think about if you have d over dx of 2x, what that gives us is 2 dx over dx, and that's where that 2 comes from. So just kind of keeping that in mind as we go. So some guidelines for implicit differentiation is that you differentiate both sides with respect to x. So we always have this dx. We obey the chain rule by multiplying dy over dx every time we differentiate an expression containing y. And we'll talk about that in a second. But essentially what that means is if you have a 2y, you still have to think about chain rule. So the derivative of 2y is 2. So keeping that in mind. And then we isolate dy over dx by getting all of those terms on one side and solving. It's not going to be bad, don't worry. So here's our first example here. It says find dy over dx for xy plus y equals 8. Now normally, if you didn't want to use implicit differentiation, you would probably try to get all your y's on one side. But I kind of see that this is going to be complicated. So let's say instead of doing that, let's just implicitly differentiate. So I'm going to say over here, we are going to be solving in terms, differentiating in terms of x at 3, 2. We can look at that in a second. So this d over dx gets applied to all these terms. We have product rule right here. I'm just going to write this out so it's very clear. We have x times y plus y equals 8. So when I'm doing this right here, d over dx, this d over dx goes to both the x, the y, and the 8. We can do that 8 really quickly. The derivative of 8 with respect to x is just 0, because the derivative of a constant, right, that instantaneous rate of change is 0. Now I'm going to use my product rule here with this x and y. I'm going to say that this is going to be dx over dx. Or actually, yeah, we can do that. Dx over dx times y plus x dy over dx plus that derivative gets applied to that y, so there's a dy over dx. Now we can simplify. We know the derivative of x is 1. So remember, you don't even really have to show that. So we have y plus, I'm just going to write this as dy over dxx plus dy over dx equals 0. And we're going to try to get this in a way where we're isolating those dy over dx terms. So I'm going to move the y to the other side, and I'm going to factor this dy over dx out of these two terms. So I'm going to have dy over dx times, this is leaving us with an x plus 1, equals, when I move that y, I get negative y. And then the last thing to do is just to isolate this. So I'm going to divide by x plus 1. So I just got the derivative of y with respect to x is negative y over x plus 1. Now it gave us a little bit more here. It said let's evaluate at 3, 2. So the next thing that we're going to do is I'm going to come in and I'm going to add this term. And I'm going to say we are going to be, and I'm going to actually erase this right here. So there we go. Now we're all good to go. And I'm going to say we're evaluating at the point 3, 2. So what that means is I'm plugging in a 3 every time I have an x and a 2 every time I have a y. So rewriting this, we have dy over dx evaluated at 0.32 equals negative 2 over 3 plus 1, which is negative 1/2. So what this is saying is at this function, this x plus y equals 8, this random function, at 3 over 2, my slope is negative 1/2. So I can actually get a tangent line pretty quickly, right? You should have like, oh, tangent line means y minus 2 equals negative 1/2. And it didn't ask us this, but this is just expanding on our knowledge here. Minus 3. And there's that tangent line equation. Pretty easy. Let's look at another one. Differentiate x plus 3xy minus 2y squared equals 2 at 1, 1. So again, we're trying to find like what is the slope. So we're saying m equals what at the ordered pair 1, 1. Again, if I look at this, it's not easy to solve for y. So implicit differentiation, you know to use it when you look at it and you're like, ooh, not easy to solve for y. So let's get this right here. We're going to do d over dx. That is getting applied to every side. You know, so I'm just going to start working from left to right. We know that the derivative of x with respect to x is 1. Next term, we know that this is going to be product rule, right? This is 3x times y. So the derivative of 3x, so you'd have 3 dx over dx is going to be 3 times y plus 3x times the derivative of y, which is dy over dx. And then here's where that chain rule is going to come into play here. You're going to say, okay, I know that this is going to be minus 4y, but then we also have that dy over dx because you're saying like the derivative, so right here we have 2 times 2 is 4, and you subtract that, so you have that 1, but then you're also taking that dy over dx, so that still has to be applied because you're taking the derivative in terms of x, so it can't go away because this is not in terms of x. The derivative of 2 is 0. Again, we're trying to simplify and get all those dy over dx's on one side. So I'm going to grab these two terms, this 1 and this 3y, and I'm going to move them to the other side of my equation. And I'm also going to factor this dy over dx out of 3x minus 4y. So I should get dy over dx times 3x minus 4y equals, whoops, should be a negative. When we move it to the other side, we have a negative 1 minus 3y. And then finally, we isolate that dy over dx by dividing by 3x minus 4y. All in all, we have dy over dx equals negative 1 minus 3y all over 3x minus 4y. Now, we can do some things here to kind of get rid of some of these negatives. So if you could also say that that's going to be 1 plus 3y over, I'm just going to move these terms, 4y minus 3x, and that is an equivalent term. That might be easier to plug in for you, but if not, it's totally fine. So now let's just evaluate this. We're going to say, all right, let's evaluate dy over dx at the ordered pair 1, 1. So what that means is that's going to be 1 minus 3 times 1 over 3 times 1 minus 4 times 1, which should just give us positive 4. So the slope at that point is going to be positive 4. We are going to go over 2 more examples, so we're just feeling ready to go. I am going to be going over, let's do example 3, and then let's also grab a funky guy. So let's maybe do example 5, and I'll just show you guys the answers for 4 and 6. So we'll be doing 3 and 5 in the video, and then I will show you guys 4 and 6. Let's change colors here. Purple. It says find dy over dx, so the derivative of y with respect to x, or in terms of x. So what I'm going to say, we're derivating this in terms of x. So we are solving for that dy over dx. So first thing, remember right here, normal rule. So this would be a 3y squared, but because it's not in terms of x, that doesn't cancel out. We have dy over dx. Next term, we're derivating this 5y squared. You know the derivative of 5x squared would be 5x, dx over dx, right? So that would cancel out. But because it's in terms of y, we're going to have 10y dy over dx. Same thing, we have a minus 5 dy over dx. Minus 2x, technically, right? Technically, that's a dx over dx. So that cancels out because that's equivalent to 1. I'm just going to erase it. And then that all equals 0. Once again, we're trying to factor out our dy over dx's, so I'm going to move that 2x over to the other side. I'm going to say dy over dx gets factored out. We're left with 3y squared plus 10y minus 5 equals 2x. And then you just divide to isolate that dy over dx. And then you are good to go. This equals, let's say equals dy over dx. I'm going to go over number 5. Number 5, we have differentiate cosine of xy equals x plus 3y. So same thing here. We have product rule. So this is actually going to be, we'll look at this in a second, but just like thinking about like all the components that are going into this. Let's use blue. So we're differentiating, so we're saying d over dx, always differentiating in terms of x. And I'm also going to add in, I'm just going to go in with a black, and I'm going to say this is going to be cosine of xy. So we're going to make sure we're using chain rule appropriately here. Remember that the derivative of cosine is sine. So I'm going to say negative sine xy times, then we do product rule on that x times y. So we have x times y, which would mean x dy over dx, because the derivative of y, plus y dx over dx, which is just 1, so I'm not even going to write it. That equals, derivative of x is 1, dx over dx, so it's just 1. Derivative, this is going to be plus 3, and then that y becomes dy over dx. So once again, let's get this all kind of like written out, because we need to get this dy over dx out of those parentheses. So I'm going to fully expand, and I'm going to say this is the same thing. I'm going to pull this guy out right here. So he's going to be multiplied by y sine of xy, negative sine of xy, and then the y is going to be multiplied by negative sine of xy. So when I do that, I get negative x dy over dx sine of xy minus y, be careful with that minus sign, sine of xy equals 1 plus 3 dy over dx. Now this is tricky because before we've had my dy and dx's on one side, so I'm going to kind of do a little bit of manipulating here to get them over to one side. I'm probably going to move, let's move this term so we can just keep everything as positive as possible. So over on my left-hand side of the equation, I'm going to have negative 1 minus y sine of xy equals. I'm moving this guy over, so I move the 1 to the left-hand side. I'm moving this term negative x dy over dx sine of xy over to the right, and I'm also going to factor out a dy over dx at the same time. So I have a dy over dx times, we already had that 3, and then we're going to have a plus x sine of xy. Last term, or last thing to do is just divide. And this is a messy answer, but that is okay because we're in calculus and life is messy. So I'm just going to get a little box right there because that all factored out. I am going to throw in the math for example 4 and 6. I would encourage you to pause the video, or the video is going to stop, but pause the video, try them on your own, and then check your work. So guys, quick go through of what we did here. I'm going to get a little scroll up. I recognized that what was going on here was product rule. Remember that the derivative of e to the x is just e to the x, but the derivative of y is dy over dx. Moving that y over e times e to the x over, divide by e to the x, and I just am left with a negative y. That next one, I rewrote, or I expanded this to 2 terms so I wouldn't have to worry about anything funky, as ln of x plus ln of y. Use those logarithm rules about how like multiplication expands to addition. And then I just used normal differentiation. The derivative of natural log of x is 1 over x, dx over dx, right? So it cancels. Natural log of y would be 1 over y. dy over dx doesn't cancel. Derivative of sine is cosine. Moving that 1 over x over, and then once we're left with 1 over y, how to cancel dividing by y would be to multiply by y. So we're just left with y times cosine of x minus 1 over x. I will see you guys on Monday. Please get some of this practice done in the little Khan Academy box.